Hello friends, in this video we will see another method to solve the system of linear equations. The method is known as reduction method. In reduction method, the first step is express the given equations in matrix form. That is A into X is equals to B, where X is unknown column matrix, that is consists of variables. A is a coefficient matrix which consists of the coefficients of the variables. B, constant column matrix. So both X and B are column matrices. After expressing it as Ax is equals to B, then we convert the given matrix or the coefficient matrix A into either upper or lower triangular matrix. After converting it into triangular matrix, then find the multiplication between that triangular matrix and X and equate it with the other side and get the answers for the unknowns. For this, we consider the one example which is from your textbook miscellaneous exercise 2B, question number 2, sixth. Solve by reduction method these equations. Equations are given to you. We see the answer. We write the coefficient matrix, that is nothing but the coefficients that we will see from the first equation will give me the coefficients 1, 3, 2. So we will write it in first row 1, 3, 2. The second equation 3 minus 2, 5. So here 3, second row 3 minus 2, 5. And the third equation has the coefficients 2 minus 3, 6. So the third row of the matrix is 2 minus 3, 6. X is an unknown matrix, column matrix, where three variables are there in which the equations are. Matrix B is the constant matrix which we will get it from the right side of the equations. That is, the first one is 6, then the followed by 5 and followed by 7. So here we are writing 6, 5, 7. Then these equations, given equations, can be written in the matrix form as Ax equals to B. So we write here A matrix and B matrix. We have seen in method 1 how the A into X really gives you the matrix B. By equating those matrices, we do get the equations which are given to you. So no need of verifying it now. Only the thing is that now we have to apply the reduction method. That is, what we are supposed to do is that we have to convert this matrix into triangular matrix, either upper triangular matrix or lower triangular matrix. But since this matrix is a prefactor, the first factor, and X is unknown here, we can check that in row transformations we have seen that the row transformations are applied only on prefactors. and here it is a prefactor which is known to you, so we will have to apply in reduction method the row transformations, and that is where we prefer now that in case of the identity matrix, what we had done was the completing the first column of identity, then switch over to the next column of identity, and then switch over to next column. So instead of that, not now what we are going to do is that for the first column, of course the first column we have to complete first, and the trick is same, that we have to convert this number into 0. So which row we are changing is R2, changes to R2. The opposite of the number is -3 times R1, since 1 was already there in the row 1. Since we are completing the first column, we will consider Rj as R1 in both the cases, and of course in R3 also we have to change R3 as R3, the opposite of 2 as -2 times R1. So the answer here is R2 minus 3 times R1. 3 minus 3 times 1 is 0, minus 2 minus 3 times 3. Minus 3 times 3 is -9, minus 2 is -11. In the same manner, 5 minus 3 times 2 is 6. So 5 minus 6 will give me -1. In the same manner, here also R2 minus, so 5 minus 3 times 6, which is 18. So 5 minus 18 is -13. In the same manner, R3 minus twice R1, so R3 2 minus twice of 1 is 0, -3 minus 2 times 3 is -6, so -3 minus 6 is -9. 6 minus 2 times 2 is 4, 6 minus 4 gives me 2, and 7 minus 2 times 6, that is 12, so 7 minus 12 gives me -5. So this is the transformation, and now we have completed the first column in which we got these two zeros. So it's just a question of getting 0 in this at this position, and of course to change it over, which row we are supposed to change is R3. So R3 changes to R3. Only the motive is we have to get 0 over here, not necessarily we have to get 1 in this case, because we are reducing it to the triangular matrix. Now here we are going to complete this triangle, means that we are reducing this matrix into upper triangular matrix, and for that we are just finding out what transformation we are supposed to do is that R3 changes to R3, no doubt about it. I want that, of course, here I have to, since the first column is complete, I will not make use of R1 now. So with the help of R2 only, I have to bring here 0. And that is why here I am writing R2. But in R2, we don't have the 1 over here. So first of all I have to bring 1 over here. How to bring 1 over here is the only way out is divide by -11. So that this becomes 1. Now when it becomes 1, the trick is same. What will be k is the opposite of 9, -9, which is +9. So that is why I am writing R3 plus 9 times the opposite of this, 9 times divide by -11, because I have to get here 1 indirectly, multiplied by R2. Now we will write the first row, second row as it is, here also as it is, only R3 minus 9 upon here it is plus minus minus, so I am saying minus 9 upon 11. So 0 minus, any times 0 is 0, and that is why we get it as 0. Here minus 9 plus 9 upon minus 11 multiplied by minus 11. So minus 11 into divide by minus 11 becomes 1 plus 9. So plus 9, and here it is minus 9, so gives me 0. The last operation, 2 plus 9 upon minus 11 multiplied by minus 1. Now this is becoming rather difficult, so I would prefer to write it as a rough work. So I am doing the rough work. See that I have told you that whenever we want to we want to calculate something, you can use your right side of the answer sheet. So here I am writing it. Of course the rough work will be done by pencil. So here I am writing 2 plus 9 upon minus 11, sorry 9 upon minus 11 multiplied by minus 1. Now I can do it fast. Minus of minus become plus, 9 by 11. So 11 into 2, 22 plus 9, 31 upon 11. So I am getting 31 upon 11. In the same manner I am finding out the same calculation here also. Minus 5 R3 plus 9 by minus 11 and multiplied by the position the element minus 13. So once again here it is minus minus become plus. So 13 nines are 117, and here 11 fives are, it will be plus no doubt. So 11 fives are 55, which has to be minus. So 117 minus 55, I had done this also, and we are getting 62 upon 11. After reducing it to the triangular matrix, here we stop and actually multiply the matrix. So what I get is first row multiplied by first column. So 1x plus 3y plus 2z. See, 1x plus 3y plus 2z, which has to be equals to 6. The second row multiplied by second column. So it will be second row. So I have to equate it by minus 13. The second row 0 times, so x is not there. Minus 11 times y minus z equals to minus 13. And the last one is 0 times x plus 0 times y plus 31 upon 11 times z is equals to 62 upon 11. See that the way we are getting the equations is that the first equation contains 3 variables, the second equation is containing 2 variables, and the third equation is containing only 1 variable, and that is why we call it as a reduction method. Okay, so here the number of variables are reduced just because of the triangular matrix. This magic is there, and of course if only one variable is there, you know how to calculate it, and we are getting z is equals to 2. Once I get the value of z, I put it in this equation to get the value of y equals to 1, and once again y and z are known to me. Put it in this equation will give me the value of x equals to minus 1. So this is known as a reduction method, and why it is called as a reduction method is we just reduce the number of variables in that case.